What do you remember about this magical idea of variation, other than you just experienced it in spades right here? You just experienced it in spades right here. Remember the idea I talked about before about how sometimes work-study students clock more hours than others? Well, but on average, they average out the same amount. So you just experienced it via random numbers. Sometimes we got 3 6s, 4 6s, sometimes no 6s. But on average, it averages out to 1 6 per trial. Pretty slick, pretty slick. So the idea now I have for you, the question I have for you is, what do you remember about this? What we were studying last week.
Bert and Ernie.
Bert and Ernie, tell me more.
Good. Who's a better student?
I forgot about Bert and Ernie. Who's a better student?
Bert.
Bert.
In my mind, anyway.
Okay, that's fine, that's fine. But how are they different? The whole point of Bert and Ernie was
Ernie was consistent.
consistency versus inconsistency. How did we eventually come around to measuring that consistency or inconsistency?
The difference from the average.
Boom! We measured the distances from average of each data point and then averaged those, like a double average, yes? Yes, and what do we call that bad boy? Good!
Yeah.
I'm going to call it the sample standard deviation. You can just call it the standard deviation. I'm totally fine with that because really there's only one of them right now we're talking about. The reason I like to include the sample is because we are eventually going to include the population, but not right now. It doesn't make any sense right now. Right now we're drawing samples. Remember what his name was? Little S. Exactly, little S. Little S. And did you hear what Carolyn said? It is, or it, she, it, he, it is, on average. I got you started. I want you to finish that. Sorry.
What do you mean, like, it's the distance from the average on
That's
average?
what I wanted to hear, Rachel.
Far.
On average, go ahead, say it again.
On average, it's the distance from the average on average.
It's the distance of each of the data points from the average on average. That's all. That's what it is. So if you look at your exam that's due next week, next Thursday, in one of those questions I asked you to explain what the standard deviation you just calculated is. And you have to say something just like that, using the number from the problem. On average, the number of eggs that your chickens lay, blah, 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 or blah, from blah. Your job is to fill in the blanks with the correct values. So it basically, it gives you an average distance. Excellent, excellent, thank you. That's the formal definition. Now I noticed you've used the word average a couple times. That's because these guys are tied together. You should never have one without the other. You should never have one without the other. And in particular, the one we're talking about right now is X bar. Right now, X bar is the one where we care the most about. Remember what X bar is? I'm sorry, it's been about a week and a half since we mentioned him by name formally. Good! The mean of your sample, the average of your sample. So add up all your sample values, divide by how many there are, boom, that's X bar. And once you have that, you can do Rachel's calculation. Now when I say do Rachel's calculation, I mean let the machines do the calculation, we interpret it. But that's what that number is in reference to. It's in reference to is X bar. Sorry, making up words, making up pronunciation. So you should never have one without the other, although you often do. You'll almost never have a variation without an average in the news, but the news is notorious for giving you this without this. And you'll see why that's important. I actually collected some data. I read a paper over the last weekend, about Facebook and sociology, and I'm like, ooh, we can do this in class. So I collected some data for you guys. We're going to play with it in the class today. And you'll see why you have to have this guy along with this guy, or else everything's meaningless. And it's very, very clever how social media ties into this one idea, how it all ties back to statistics. So we'll finish with that today. Questions so far? How do you interpret the size of S? Like when S is big, what does that mean? Big. Say that again, Emily. Inconsistent data, spread all over the place, yeah? Bert. When it's small, it's consistent, right? Not variant, not very variant. What is big and what is small? That's a trick question, FYI.
Wider,
that's
average,
big.
wider.
It's like when my son goes, I love you this much, Daddy. I'm like, can you get wider? I'm like, no, I'm 6.
You said it's
My arms go this wide.
Depends.
It depends. That's why it's a trick question. You might have a standard deviation of 1. And you go, oh my God, that's super tiny. Well, no, not if the standard deviation is measured in inches and you're talking about the variance in the size of a bolt. Then 1 inch not only is not small, it's unacceptable. You don't want variances that are measured in inches when you're talking about a bolt that has tolerances of thousandths of an inch. You're 1,000 times too big. So one could be exceptionally, it all depends. Corbin has the best answer. It depends. You have to look at it contextually and decide what big and small is. And we'll do that all through, I promise. Those are going to be trick questions on assessments. There's going to be kind of things like, interpret this, what do you think? And there's going to be a whole host of answers to that. So just keep that in the back of your mind. You can't just look at a number, 12, and say that's big or that's small. You have to compare it to something else. 12 what's, first of all, what's the unit? And secondly, can you compare it to some other variation? And that's why I wanted to start with the data set from today. If you look on the data sheet, which some of you might still need, does anybody still need a data sheet? I brought a few extra copies if